Hello and welcome to video lecture on entity relationship model. In this video lecture, we will discuss on how to identify entity and their attributes. By the end of this video lecture, students will be able to identify entities and attributes of a given problem statement. Entity relationship model was proposed by Peter Chen in the year 1971 to create a uniform convention which can be used for relational database and network. He aimed to use this model as a conceptual modeling approach. The entity relation model is a high-level conceptual data model diagram. Entity relation model is based on the notion of real world entities and their relationship between them. ER modeling helps you to analyze data requirements systematically to produce a well designed database, so it is considered a best practice to complete ER modeling before implementing your database. And it is very useful in mapping the meaning and interactions. Now, let us see the components of ER diagram. This model is based on three basic concepts: entities, relationships, and attributes. Consider an example here. A university database might have entities like students, courses, and teachers. Further, students have attributes like roll number, name, and department ID. Hence, they might have relationships with courses and teachers. Here is an example. You can see the entities can be a car, can be a student, etc., about which a data is to be maintained in the database. Further, these entities can have the characteristics like color of a car, full name of the student, etc. A relationship can be an association between the instances, one or more entity types. Let us see these entities and attributes in detail. An entity can be a real world object or a thing that can be easily identifiable. For example, in a school database, students, teachers, classes, and courses offered by a school can be considered as entities. An entity can be a place, person, object, event, or a concept which stores data in the database. The characteristics of entities must have an attribute and a unique key. Even every entity is made up of some attributes which represent that entity. Consider some examples of entities. Person like employee, student, patient, doctor are considered as entity. Places like store, building, objects like machine, product, car are considered as an entities. Entities are represented by their properties and values called attributes. An entity set is a collection of similar type of entities which share the same properties. For example, student set may contain all the students of a school. Likewise, a teachers may contain all the teachers of a school. Entity set may contain entities with attribute sharing similar values. Entities are represented by their properties, which are also called as attributes. Also, all attributes have their separate value. For example, in this diagram, you can see a student is an entity which has different properties like student ID, name, class, and date of birth. Similarly, an instructor can also have different properties like instructor ID, department, courses, etc. Relationship set. The association among entities is called a relationship. Example, instructor instructs student. Here, keyword instructs is called relationship. Similarly, we can take one more example. Tom works in chemistry department. Here, keyword works is called relationship. A set of relationships of similar type is called a relationship set like entity. Relationship can also have attributes. These attributes are called descriptive attributes. Entities are represented by means of their properties called attributes. All attributes have values. For example, a student entity may have student ID, name, class, and date of birth as an attributes. There are different types of attributes: simple attribute, composite attribute, derived attribute, and multi-value attribute. Let us see one by one. Simple attribute can't be divided any further. For example, student's contact number. It is also called an atomic value. As we know, contact number cannot be divided any further, hence it is grouped under simple attribute. Composite attribute. It is possible to break down composite attribute into further. For example, student's full name can be further divided into first name, middle name, and last name. Multi-value attribute. These can have more than one values. Example, students can have more than one mobile number, more than one email addresses, etc. Last one, derived attribute. This type of attribute does not include in the physical database. However, their values are derived from other attributes present in the database. For example, age should not be stored directly. Instead, it should be derived from the attribute date of birth of that employee. Now consider a problem statement here. UPS prides itself on having up-to-date information on the processing and current location of each shipped item. To do this, UPS relies on a company-wide information system. Shipped items are the heart of the UPS product tracking information system. Shipped items can be characterized by item number, weight, dimensions, insurance amount, destination, and final delivery date. Shipped items are received into the UPS system at a single retail center. Retail centers are characterized by their type, unique ID, and address. Shipped items make their way to their destination via one or more standard UPS transportation events, that is, flights, truck deliveries, etc. These transportation events are characterized by a unique schedule number, a type, example, flight, truck, van, etc., and a delivery route. Now, let us find out the entity and attributes in this problem statement. Here, shipped item transportation event retail centers can be considered as entities because these are unique concepts based on which a data is stored in database. Further, these entities have their properties, that is attributes, as shown here. Shipped item will have attributes like item number, weight, dimension, insurance amount, destination, delivery date, etc. Similarly, A transportation event will have attributes like type, delivery route, and schedule number, etc. Finally, a retail center have the attributes like unique ID, type, address, etc. Consider one more problem statement here. Consider a car insurance company whose customers own one or more cars each, and each car has associated with it 0 to any number of recorded accidents. Each insurance policy covers one or more cars and has one or more premium payments associated with it. Each payment is for a particular period of time and has an associated due date and the date when payment was received. Now, pause the video for some time and think and write down the entities and attributes for this problem statement. Solution for this problem statement is as follows. Car, policy, accident, premium payment can be considered as entities because these are unique concepts based on which a data is stored in the database. Further, these entities have their properties as shown here. Customer will have attributes like customer ID, name, address. Similarly, car will have attributes like license number, model. Policy can have the attribute like policy ID. Accident can have report ID, date of accident, place of accident, and finally, premium payment can have attributes like payment number, due date, amount, received on, etc. Thank you.